Good morning. From where I left, that is, I stopped in the last class. I'm going to continue now. I had given one problem, discuss the convergence of the series 1 by 3 whole squared plus 1 into 2 by 3 into 5 whole squared plus 1 into 2 into 3 divided by 3 into 5 into 7 whole squared plus 1 into 2 into 3 into 4 by 3 into 5 into 7 into 9 whole squared plus etc. till infinity. Okay, I had given one problem. Now we are using here time being the first concept, that is D'Alembert's ratio test. I'm just recalling what you have done in the previous class. We are using D'Alembert's ratio test. Okay, D'Alembert's ratio test. Now D'Alembert's ratio test, name itself says ratio. D'Alembert's ratio test means that is limit n tends to infinity. The concept of limit you have studied in first semester also in Maths 1 first semester, and also in PUC you have studied quite a bit of limits. So here the concept of limit plays a vital role here, especially limit n tends to infinity. So limit n tends to infinity un plus 1 divided by u1. This is D'Alembert's ratio test. Again I repeat, limit n tends to infinity un plus 1 divided by un. Okay, what is this un plus 1 and un? Un is the nth term of the given series. Un plus 1 is the n plus 1 term of the given series. So we have to find the ratio of the two terms. We have to find the ratio of the two terms. That is un plus 1 divided by un. Okay, for that what we do? We have solved many problems. Once again I am telling you, all the students, write down and study and write the notes. The PDF I am sending to your group, please write the notes. And at last you will not get time to write the notes, study and write the exam. So you will be in trouble. So now only write the notes and start preparing. It's very easy. Okay, any doubt you can tick in pencil, come and ask me later. So first we take sigma un. So what is sigma un? Sigma un is 1 by 3 whole squared plus 1 into 2 by 3 into 5 whole squared plus 1 into 2 into 3 by 3 into 5 into 7 whole squared plus all this. The given problem is written till infinity. That is the given series. Sigma un is the given series. Sigma un is the given series. Okay. Then we have un. What is un in this? So un will be equal to 1 into 2 into 3 into 4 till n divided by 3 into 5 into 7 into 9 till, that is odd terms, that is 2n plus 1, that's nth term. You know how to find nth term. There is a common difference here, 3 plus 2 5, 5 plus 2 7, 7 plus 2 9, I told in the previous classes. So the nth term can be found out by using the formula a plus n minus 1 into d. That is nothing but 3 plus n minus 1 into 2. So 3 plus n minus 1 into 2 means it will be 2n plus 3 minus 2, that is plus 1. Very simple. A plus n minus 1 into d if it is in the arithmetic progression. A into r power n minus 1 if it is in the geometric progression. And harmonic means it is the reciprocal of arithmetic progression. This all you know from a high school level. So this is a very simple. Numerator is the nth term. First term is 1, second term is 1 into 2, third term is 1 into 2 into 3, fourth term is 1 into 2 into 3 into 4. So naturally the nth term will be 1 into 2 into 3 into 4 till n divided by, first term is 3, second term is 3 into 5. So you can see odd numbers, 3 into 5. Third term is 3 into 5 into 7. Next term is 3 into 5 into 7 into 9. So naturally it will be 3 into 5 into 7 into 9 till 2n plus 1. So how you get 2n plus 1? Because it is an arithmetic progression. There is a common difference 2. 5 minus 3, 2, 7 minus 5, 2, like that. So we can use the formula to find the nth term, a plus n minus 1 into d, and find out the nth term. Okay. Once you have got it, then we find, once you have written this un, that is the nth term of the given series, then you write un plus 1 here. Then you write un plus 1. Okay. What is this un plus 1? So un plus 1 will be equal to, this term is there. Already the un term is there. So what will be un plus 1? So un term is already there. So one more than that. this is un term. So suppose it is u7, then it is the 7th term. Then n plus 1 will be 8th term. That's all, the next term. So the next term, naturally, wherever there is n, put n plus 1, because the next term has to come. Wherever there is n, put n plus 1. So that's all. 1 into 2 into 3 into 4 till n. So the next term will be n plus 1. Same type of term, but wherever there is n, the next term will come, that is n plus 1. Similarly, 3 into 5 into 7 into 9 till 2n plus 1. So the next term will be replace n by n plus 1. So 2n plus 2 plus 1, that is 2n plus 3, so square. Okay, so now un plus 1 divided by un plus 1 divided by un will be, first I write the un plus 1 term, 1 into 2 into 3 into 4 till n into n plus 1 divided by 3 into 5 into 7 into 9 till 2n plus 1 into 2n plus 3, your bracket should be there, whole squared, divided by un. So un is this term. Okay, un is this term, you know that. Now, when you are writing un, it should be reciprocal. When you are writing un, it should be the reciprocal. Reciprocal means, first you are writing 3 into 5 into 7 into 9 till 2n plus 1 divided by 1 into 3 into 4 till n. So, whenever you are writing the denominator, that is un, when you divide the denominator of a fraction, when you divide two fractions, the denominator will be the reciprocal. So this will be 3 into 5 into 7 into 9 till 2n plus 1 into 2n plus 3 divided by 1 into 2 into 3 into 4 n into n plus 1. Okay. So that is n plus 1th term. Now nth term divided by nth term means we have to write the denominator first in the numerator. So denominator will be numerator, numerator will be denominator, because it is division. Very simple concept. All of you know it. Okay. Now, when you look at this carefully, you can use your laws of indices and multiplication rules, what you studied in your high school and elementary, that is after 7th standard till 10th standard, to solve this. What happens? 1, 2, 3, 4 till n get cancelled. 1, 2, 3, 4 till n get cancelled. Here, 3 into 5 into 7 into 9 till 2n plus 1 get cancelled. So now question comes, what is left? So the term left here is 1 is here n plus 1, because n cancelled, n plus 1. Another till 2n plus 1 cancelled, so the term left is 2n plus 3. So we got 2n plus 1 divided by 2n plus 3, and the square is there. So n plus 1 divided by 2n plus 3 whole square. N plus 1 divided by 2n plus 3 whole square. So this will be the un plus 1 divided by un. This will be un plus 1 divided by un. So n plus 1 divided by 2n plus 3 whole square. This will be un plus 1 divided by un. Okay. Now, when you apply the limit to this, limit n tends to infinity, limit n tends to infinity, limit n tends to infinity, un plus 1 divided by un. If you apply the limit for this, limit n tends to infinity, un plus 1 divided by un. Okay. You have to apply the limit here. So you already studied in your first semester in Maths 1 how to find limits, different type of problems. Also you studied this concept in QC, in limits and continuity. So it should not be difficult for you. Whenever there is limit n tends to infinity, we remove this value of n outside, so that we try to bring 1 by n, because limit n tends to infinity, 1 by infinity is 0. So when we remove this n outside, it will be n into 1 plus 1 by n. When we remove n outside here, it will be 2 plus 3 by n. Okay, when we remove n outside here, 1 plus 1 by n. When we remove n outside here, 2 plus 3 by n. So square. N and n get cancelled. Limit n tends to infinity, 1 by infinity, 1 by infinity and 3 by, these are all zeros. So we are left with only 1 by 2 squared. So 1 by 2 squared will be equal to 1 by 4. Now, we got the limit. Limit n tends to infinity, un plus 1 divided by un. You got limit n tends to infinity, un plus 1 divided by un, and the value is 1 by 4. You got it as 1 by 4, right? Now, to see whether the series converges or diverges, we have to see whether the limit n tends to infinity, un plus un is less than 1 or greater than 1 or equal to 1. That's different. Equal to 1 means we cannot test. Test fails. Okay, now you can see here clearly limit n tends to infinity, un plus 1 divided by un is 1 by 4, and 1 by 4 is always less than 1. So by the D'Alembert's ratio test, So by D'Alembert's ratio test, the series sigma un is convergent. By D'Alembert's ratio test, the series sigma un is convergent. Okay. By D'Alembert's ratio test, the series sigma un is convergent because it is less than 1. Because it is less than 1. Okay. The series sigma un is convergent. See, once again, I would like to tell all the students, don't go to share the contents, don't play with anything, the gadget, the mobile you have or the laptop you have, when class is going on, because if you press anything, here the class will be disturbed. As a result, the video is a recorded video, the video will get spoiled. The class will get spoiled. So please don't touch anything. Any doubt you can ask through the groups or you can ask me later. Here I can't solve any doubt also because it's not a live classroom. It is an online class. You should understand that. Okay. So now by D'Alembert's ratio test, again problem is. Okay, now by D'Alembert's ratio test, the series sigma un is convergent. Why? Because we got limit n tends to infinity un plus 1 divided by un is equal to 1 by 4 and 1 by 4 is less than 1. If it is less than 1, by D'Alembert's ratio test, the series sigma un is convergent. This all of you know. I need not say, you know it also. Now, we go to the, therefore sigma un is convergent. Greater than 1 means divergent and equal to 1 means the test fails. Okay, that's all. This is what? This is D'Alembert's ratio test. For the students who came late, I'm telling, we are going to complete it today. I have solved lot of problems. You don't study anything else knows. Study first the problems done in the class. You should know how to do the problems done in the class and then model question paper problems. So much is more than enough to get first class. I am telling you again and again. So, test for convergence the series 1 plus 2 by 5x plus 6 by 9x squared plus 14 by 17x cubed plus etc. till infinity. So, test for convergence this series 1 plus 2 by 5x plus 6 by 9x squared plus 14 by 17x cubed plus etc. to infinity. What is x? X is greater than 0. Here x is greater than 0. Now here, let sigma un be equal to these terms. 1 plus 2 by 5x plus 6 by 9x squared plus 14 by 17x cubed etc. till infinity. Okay. I wrote the given problem. Sigma un means nothing but the given problem. Sigma un means it is the given problem. Okay, sigma un is nothing but the given problem. I wrote the given problem as it is. Sigma un, the given series, I can say. Then I am writing un because for D'Alembert's test, the formula ratio test, D'Alembert's ratio test means limit n tends to infinity, un plus 1 divided by un. So here first we write the nth term, that is un, nth term un. Okay. So un is equal to 2 power n plus 1 minus 2 divided by 2 power n plus n plus 1 plus 1 into x power n. See, why I wrote that? Because see, this term, see first term you neglected. Neglecting this is very difficult to write this, the nth term of this series, because it is not in proper, very simple order as in other. It is not arithmetic progression. See, for example, 2 plus 4, 6. 6 plus 4 is not 14. So like that, it's not in arithmetic progression, it's not in geometric progression. So then we have to think our knowledge of series, how to write the nth term. So all different adding, subtracting, multiplying, 2 powers, 3 powers. So when we think like that, we get this formula. This formula you have to think and do. There is no ready-made method for this, like arithmetic progression, geometry, nothing like that. You have to think and do it. So all different trial and error methods. Okay, different trial and error methods. So now 2 power n plus 1 minus 2 divided by 2 power n plus 1 plus 1. So 2 power n plus 1 minus 2. For example, first term keep as it is, because it is power 0. There is nothing to do with that. Second term, say 2 power, second term, if I have 2 power 2 plus 1 means it is 2 power, this you take as the first term. Okay, first term. This is 0 term, I think, first term. So 2 power, first term is 1 plus 1, 2, that is 4. 4 minus 2 is 2. So first term, 2 plus 1 is 3, that is 2 power 3 is 8. 8. So here I put it as first term, 1 plus 1, 2. 2 power 2 is 4. 4 plus 1 is 5. First term. Put n equals 1. Okay, then if you want this, first term you keep as it is. First term you keep as it is. Put here n equals 2. If you put n equals 2, 2 plus 1 is 3. So 2 power 3 is 8. 8 minus 2 is 6. So 2 power 3 is 8. 8 plus 1 is 9. And n is 2. See, x power, you get this. Put n equals 3. Put n equals 3. Okay, if you want n equals 3, same thing, same method. Put n equals 3. So what you get? 3 means 3 plus 1, 4. 2 plus 4 is 16. 16 minus 2 is 14. 3 plus 1, 4. 2 power 4 is 16. 16 plus 1 is 17. Then n is 3. So n is 3. Like that. This formula holds good for this, except neglecting the first term. First term you can take it as the 1. That is the fixed term, because x power 0 is 1. Like that. X power 0. Keep it like that. X power 0 is 1. So this type of problems you have to think of solving like this. You have to think of these type of problems. You have to think of solving in this method. Okay, this is the method. There is no standard method for this, but trial and error method. What knowledge you have of writing the nth terms from your 8th, 9th, 10th PU level mathematical knowledge. Okay, then un plus 1 equals here. What we do here, see. Wherever n, put n plus 1. Wherever n, you put n plus 1. So what happens? N plus 1 means n plus 1 plus 1. 2 power n plus 2 minus 2 divided by n plus 1. 2 power n plus 2 plus 1. X power n plus 1. So here, what happens here? This is n plus 1th term. Now for the D'Alembert's ratio test, we need un plus 1 divided by un. So I wrote this un plus 1 term here. 2 power n plus 2 minus 2 divided by 2 power n 2 plus 1 into x power n plus 1. Then divide by un. That is 2 of divided by un means I have to write this. Divided by. Divided by means the fraction will be reciprocal. The denominator will be numerator. The numerator will be denominator. So 2 power n plus 1 divided by 2 power n plus 1 minus 2 into 1 by x power n. Here you remove 2 power n plus 2 outside. You remove 2 power n plus 2 outside, I get 1 minus 2 by 2 power n plus 2. 2 power n plus 2, if I remove outside, 1 minus 2 by 2 power n plus 2. Here 2 power n plus 2 outside, 1 plus 1 by 2 power n plus 2. This will be x power n into x power 1. X power n into x power 1 written here. Okay, I hope it is clear. Why we do this? Because we want n in the denominator. This is the concept you studied right from PUC and last year also in Maths 1. How to evaluate limits when it is n tends to infinity, because limit n tends to infinity, 1 by n is 0. Coming to this, I remove 2 power n plus 1 outside. So 1 plus 1 by 2 power n plus 1. Here also in the denominator, I take 2 power n plus 1 outside. 2 power n plus 1, 1 minus 2 by 2 power n plus 1, and then 1 by x power n as it is. Now cancelling comes into picture here. So these terms cancel, this term also cancel, x power and cancel. So finally we are left with, you can see it's very simple. You can see here clearly we are left with 1 minus 2 by 2 power n plus 2, 1 plus 1 by 2 power n plus 2 into x. So 1 plus 1 by 2 power n plus 1, 1 minus 2 by 2 power n plus 1. This x power n cancels, only x is left, like this. So this is the term un plus 1 divided by un. This is the term un plus 1 divided by un. Now we apply the limit for this. That is to find D'Alembert's ratio test to judge what type of answer you are getting. Limit n tends to infinity, un plus 1 divided by un. Limit n tends to infinity, un plus 1 divided by un. So you know many problems you have done till now. Practice all the problems. It will be very easy if you have practiced. So limit n tends to infinity we apply here. So this will be 0, because 2 by 2 power n. 2 power n means 2 power infinity. That will be infinity. So 2 by infinity, n plus 2, 2 power n plus 2, 2 power n plus anything. 2 power infinity is infinity. So 2 by infinity is 0. Here also 1 fixed constant. Divide by 2 power infinity. N is infinity. So 1 by infinity is 0. So here you have got 1. 1 minus 0, 1, 1 plus 0, 1. Coming to this, x as it is, because n tends to infinity. 1 plus 1 by 2 power infinity is infinity. So 1 by infinity is 0. So 1 plus 0. Here 2 power infinity is infinity, 2 by infinity is 0. So 1 plus 0 divided by 1 minus 0. So totally it will be equal to x. So we got limit n tends to infinity, un plus 1 divided by un is equal to x. Limit n tends to infinity, un plus 1 divided by un is equal to x. Okay. Now, here what happens? By D'Alembert's ratio test, now we got x. X is not a finite number. The question comes there. X is not a finite number. X is a variable. So what to do now? Limit n tends to infinity, un plus 1 by un is equal to 1. Test fails. Less than 1 converges. Greater than 1 diverges. But x we cannot say whether it is 1 or what it is. So how we proceed? We write the rules of D'Alembert's ratio test. We write the rules of D'Alembert's ratio test. What we write? By D'Alembert's ratio test, the series sigma un is convergent. By D'Alembert's ratio test, the series sigma un is convergent for x less than 1. Divergent, as it is we write the rule, because less than 1 means convergent. So, by D'Alembert's ratio test, the series sigma un is convergent for x less than 1. Divergent for x greater than 1. And the ratio test fails when x equals 1. So instead of writing the constant number, we take x only. So sigma un is convergent here by D'Alembert's ratio test when x is less than 1, divergent when x is greater than 1, and the test fails when x is equal to 1. Now we'll see what happens when you put x is equal to 1. For 2 convergent we got divergent, but when x is equal to 1, what happens? Test fails. But what happens to the series? We have to see that. When x equal to 1, we have un equals here. When x equals 1, you know 1 power anything is 1, 1 power 100, 1 power 1000, 1 power n 1. So when x equals 1, un will be 2 power n plus 1 minus 2 divided by 2 power n plus 1 plus 1. So we apply limit for that. We use the necessary condition. The beginning we have studied necessary condition. We use that. Limit n tends to infinity, un, what happens? When you apply the limit n tends to infinity, we get remove 2 power n plus 1 outside, because n tends to infinity. I need not say it every time. You have to bring n to the denominator. So 2 power n plus 1 outside, 1 minus 2 by 2 power n plus 1, close the bracket. Here 2 power n plus 1 outside, 1 plus 1 by 2 power n plus 1. This, here what happens, the 2 power n plus 1, 2 power n plus 1 get cancelled. Then when I apply the limit n tends to infinity, this will be 2 power infinity. 2 power infinity will be infinity, 2 by infinity will be 0. So 1 minus 0, here also n is infinity, infinity plus 1 is infinity, 2 power infinity is infinity, 1 by infinity is 0. So 1 minus 0, 1 plus 0 is 1. This get cancelled, so 1. And 1 is not equal to 0. So the necessary condition, see the beginning of the notes. If you see the notes, you can make out. I have given in the form of condition. So by necessary condition, for the convergence of a positive sum series, I have given, see the beginning of the notes. The necessary condition for the convergence of a positive term series. By that, the necessary condition for the convergence of a positive term series, sigma un is divergent when x equals 1. Okay. Then the given series is convergent. So when x equals 1, what you get 1? Not if it is 0, it was convergent, but you got 1. So when you get 1, it means it is not equal to 0. So by the necessary condition, it is divergent. So we say sigma un is divergent when x equals 1. So though the ratio test fails, we apply it for un and use the necessary condition. Limit n tends to infinity un. If it is 0, it is convergent. Not equal to 0, it is divergent by the condition. See the condition. Therefore, sigma un is divergent when x equals 1. Thus we say that combine all the results together. The given series is convergent for x less than 1, divergent for x greater than 1, but also. So, therefore we can say the given series is convergent. Very clearly we got before here, see here. So convergent for x less than 1, divergent for x greater than 1, but for equal to 1 also we got divergent. So we boldly write it's convergent for x less than 1 and divergent for x greater than or equal to 1. Now I have given 2 problems for homework here. That is, you have to do it because very important. It is just like the previous problems I have done in the model question paper. Model question paper problems I have solved same type of problem, so it is given for homework. Okay. Test for convergence, the series sigma n is equal to infinity, 1 into 3 into 5 into 7, 2n minus 1, 4 into 7 into 10 till 3n plus 1. That is, see the same type of problem I have solved. Solve it in the same way. Test for convergence of the series 1 by 1 factorial, 2 squared by 2 factorial, 3 squared by 3 factorial. So what will be nth term here? Here nth term will be this only, un, and then replace n by n plus 1. Here nth term will be first term 1, second term 2 squared, third term 3 squared. So nth term will be n squared by n factorial. Same type of problem is being done. See and solve it. Okay. Don't get, we'll say ask me, or the class you can ask later. Next we come to the concept of Cauchy's root test. What is the Cauchy's root test? Let un be a series of positive terms such that, see, let un be a series of positive terms. See, another test we are studying. This you have to by heart. You have to know carefully. Let sigma un be a series of positive terms such that limit n tends to infinity un power 1 by n is lambda. Let sigma un be a series of positive terms such that when you apply the limit un power 1 by n tends to infinity, we get a constant lambda. Then the series is convergent if lambda less than 1 and divergent if lambda is greater than 1. And the root test, this is called Cauchy's root test. Root test fails when lambda equals 1. So after D'Alembert's ratio test, we come to Cauchy's root test. We'll see one simple problem. Test for convergence the series. See, 1 by 1 power 1, 1 by 2 squared, 1 by 3 cubed to infinity. So sigma un, I wrote the given series 1 by 1 power 1, 1 by 2 squared, 1 by 3 cubed to infinity. So the nth term will be, you can make out, first term is 1 by 1 power n, 1 power 1, second term is 1 by 2 squared, third term is 1 by 3 cubed. So nth term un will be 1 by n power n. All these type of power n, we use Cauchy's root test. So limit n tends to infinity un power 1 by n, limit n tends to infinity un is 1 by n power 1 by n. Now 1 power anything is 1. 1 power 1 by n, 1 power 100 is 1, divided by, when you take n power 1 by n and n get cancels. So limit n tends to infinity, 1 by infinity is 0, less than 1. So lambda is 0, that is less than 1. Therefore by Cauchy's root test, the series sigma un is convergent. Therefore by Cauchy's root test, the series sigma un is convergent. Very simple. We will see another problem. Test for convergence the series sigma n is equal to 1 to infinity 1 plus 1 by root n power minus n power 3 by 2. Okay, this is sigma un, the series. They have given the nth term. So limit n tends to infinity 1 plus 1 by root n power minus n power 3 by 2. So un, this is the nth term, I take it as un, 1 plus 1 by root n minus n power 3 by 2. Now here, since it is power n and all that, we use Cauchy's root test, will be easier. Limit n tends to infinity un power 1 by n, limit n tends to this power 1 by n. So here, see what I have done. This can be written as c minus. You can write as c minus. So a power minus n can be written as 1 by a power n. You know, by indices. A power minus n is 1 by a power n. Limit n tends to infinity 1 by 1 plus 1 by root n power 3 by 2 power 1 by n. 1 power anything is 1. 1 power anything is 1. Here, this and this. So n power 3 by 2 into 1 by n. That is n power 3 by 2 by n. 3 by 2 minus 1 is half. 3 by 2 minus 1 is half. So you get 1 plus 1 by root n power root n. This is nothing but you have a standard formula in your, we use many times. That is limit n tends to infinity 1 plus 1 by n power n is equal to e. Many times it has come. We used in the previous class also. Limit n tends to infinity 1 divided, limit n tends to infinity 1 plus 1 by n whole power n is equal to e. Limit n tends to infinity 1 plus 1 by n whole power n is equal to e. So this will be 1 by e, and e is a number in between 2 and 3. So 1 by 2, that is certainly less than 1. You can see in the calculator. So by Cauchy's root test, the series sigma un is convergent. So by Cauchy's root test, the series sigma un is convergent. Okay. Now we take another problem. 1 plus x by 1, x squared by 2 squared, x cubed by 3 cubed to infinity. X is greater than 0. So un equals the same 1 plus x by 1, x squared by 2 squared, x cubed by 3 cubed, etc. to infinity. So what will be the nth term? So nth term will be here x by 1, then x squared by 2 squared, x cubed by 3 cubed. So if you take this as the first term, 1 means you take x power 0. That is x power 0. Leave it. Whenever there is 1 plus x. Already we have seen one problem before. So this is the first term, x power 1 by 1. Second term, x squared by 2 squared. Third term, x cubed by 3 cubed. So nth term will be x power n by n power n. That is x by n whole power n. You know, by indices rule. So limit n tends to infinity un power 1 by n. Limit n tends to infinity x by n whole power n power 1 by n. 1 by n get cancel. Limit n tends to infinity x by n, x by infinity. So it is 0. So 0 is less than 1. So limit n tends to infinity un whole power 1 by n, 0 less than 1. Therefore, by Cauchy's root test, the series sigma un is convergent. Greater than 1 means divergent, less than 1 means convergent. And I have given one problem for homework. Already 2 problems in the D'Alembert's test. In this I will solve in the next class. That I will not solve. Already it is solved. That type of problems it will solve. You have to solve it, the 2 problems. This problem I will solve in the next session tomorrow. Please try it. If you get the answer, this has to be done by Cauchy's root test. So test for convergence, the series sigma n is equal to 1 to infinity n cubed by 3 power n. So summarizing today's class, we solved some problems in D'Alembert's ratio test. Then we introduced Cauchy's root test and solved 2 or 3 examples. And one problem I gave for assignment. Now, in the exam, if they give just test for convergence, you can give any test. You can use either necessary condition or you can use Cauchy's D'Alembert's ratio test or Cauchy's root test. But if they give test the convergence by Cauchy's root test, then you have to use Cauchy's root test only. So you have to know that. This problem you can use any method, but since I am solving problems in Cauchy's root test, I want all of you to use Cauchy's root test and solve this. I'll discuss in the next session. So I wind up here. Time up already, half an hour. So I wind up the class here. So once again, I remember all of you, please write the notes and study mathematics by writing. You can't read mathematics. Okay? Attend the classes. Those who miss the class, please see the YouTube videos again and again. See the PDF notes. Write it and study. Write it and study 2-3 times and prepare for the exam. Okay? All the best. Thank you.